Hey everyone, welcome. Today we're diving into the world of statistical testing, specifically how the z-test and t-test are related. We'll take it slow to avoid any statistical indigestion. This is part 3 of our series, and we'll see that t-tests are related to z-tests. Before we jump straight into t-tests, we need to warm up with the normal distribution. A lot of explanations treat the z-test and t-test as totally separate things, but they're actually closely connected. Understanding the normal distribution is essential because at their core, z-tests and t-tests share the same foundational principles. So let's get comfortable with the normal distribution first. Here's what a normal distribution looks like. It's that classic bell shape. The very center is the mean, often called mu. If you go one standard deviation to the right, that's mu plus sigma. One standard deviation to the left is mu minus sigma. These standard deviations define areas under the curve. About 68.2% of the data falls within one standard deviation of the mean, 95.4% within two, and a whopping 99.7% within three standard deviations. Let's nail down some key properties of the normal distribution. First, that bell shape. It's symmetrical around the mean. The tails of the distribution get closer and closer to zero, but never actually touch it. A normal distribution is entirely defined by its mean and standard deviation. Change those, and you get a totally different normal distribution. The area under the curve represents probability. The entire area under the curve is equal to 1, representing 100% probability. Calculating probabilities using a normal distribution involves integration, which can get a bit intense. Now, let's talk about the standard normal distribution. This is a special case where the mean, mu, is 0 and the standard deviation, sigma, is 1. Why do we care? Because it saves us a ton of work. Instead of integrating an infinite number of different normal distributions, we can use the standard normal distribution as a reference. I know it sounds abstract, but stick with me and I'll show you an example. Okay, let's say we give an English proficiency test to 1,000 incoming college freshmen. The scores follow a normal distribution with a mean of 82 and a standard deviation of 5. What's the probability that a student scores between 82 and 90? We could integrate under the normal curve from 82 to 90. Good luck with that. Instead, we'll use the standard normal distribution. To use the standard normal distribution, we need to convert our scores into z-scores. The z-score tells us how many standard deviations away from the mean a particular score is. The formula is simple: z equals x minus mu divided by sigma. For a score of 90, z equals 90 minus 82 divided by 5, which is 1.6. So a score of 90 is 1.6 standard deviations above the mean. Now we can use a standard normal distribution table to find the probability of getting a z-score between 0 and 1.6. These tables are readily available online or in statistics textbooks. They show the area under the standard normal curve to the left of a given z-score. We look up 1.6 in the table. In a standard normal table, we find that the area to the left of a z-score of 1.6 is 0.9452. Remember that the area to the left of 0 is 0.5, since the standard normal distribution is centered at 0. The area from 0 to 1.6 is then 0.9452 minus 0.5, which is 0.4452. This means that 44.52% of the students scored between 82 and 90. And so, since we have 1,000 freshmen and 44.52% score between 82 and 90, we can estimate that about 445 students fall into that. See how we use the standard normal distribution table to avoid integration. Pretty neat, huh? Let's keep going with the normal table to find other values. And let's find more practice with the table, just to be sure. Time for another chance to practice with the normal table. Let's go one more time with practice using the table. Okay, so what do we do with all this normal distribution knowledge? We use the normal distribution, or more specifically, the standard normal distribution. You might be asking, okay, probability is cool, but how does this connect to hypothesis testing? Remember back in the first lecture, we asked the question, what's the probability of an event happening by chance? That probability is the area under the normal distribution curve. So, if we go back to our original question for the t-test, what's the probability that the average height of male students at University A, say 5 feet 10 inches, is the same as the average height of male students at University B, say 5 feet 11 inches? We're really asking, is that 1 inch difference likely to happen by random chance? While t-tests don't use the normal distribution directly, they do use a similar concept with a different distribution curve. That wraps up this segment. Hope you're not feeling too statistically full. We've explored the crucial link between the normal distribution and hypothesis testing. Now we can move forward. Remember, take it slow, and you will understand the connection between z-tests and t-tests. See you next time.